3.1. Factoring the GCF and difference of two squares. Let's start with a quick game of Balderdash. In case you're not familiar with it, Balderdash asks you to figure out which of these four definitions is correct. Is factor a position in a circumstance, the action of simplifying a fraction, a number multiplied times another number to create a product, or a really cool TV show followed by the letter X? Hopefully you guessed number 3. A number multiplied by another number to create a product. Let's try another one. To factor a polynomial. The method used by doctors to help people suffering from insomnia. To FOIL. A method used to reverse FOIL. Or not a cool show on TV. To factor a polynomial is the reverse FOIL. GCF. Short for GCFM, going cuckoo from mathematics. Acronym for greatest common factor. The original name of KFC. Or just 3 random letters in the alphabet. Hopefully you guessed number 2, an acronym for the greatest common factor. So, now that we understand what a common factor is, we should remember that we pull out a GCF, and then that leaves us with our 2 remaining factors. So, let's first name the GCF, then we'll factor. So, in 5x minus 20, what is our GCF? Well, the most common term is 5. 5 goes into both 5 and 20 evenly, and it's the highest value that will go into both terms. So 5 is our GCF. Well, if I divide both terms by 5, what am I left with? Well, let's divide 5x by 5. We're left with just x. Minus, well, let's divide 20 by 5. Now we're left with just 4. Well, those are now my factors. You could write them both in parentheses so that it's a little bit more obvious that you're multiplying a number times a number. But you don't have to write them in parentheses. It's actually more commonly seen without the parentheses on the first term. So 5 times the difference of x minus 4. X cubed plus 4x squared. Now, when we say GCF, we do not just mean what number is our greatest common factor. Because remember, we are now using variables that represent numbers. And so we can represent values with greatest common factor variables. So what is the greatest common factor in these 2 terms? If you need to, remember that you can write this in expanded form. That would be x times x times x plus 4 times x times x. And that makes it very clear that we have 2 x's in this term. We have 3 x's in that term, but our common factor is the fact that both terms hold 2 x's. So we call that x squared. X squared would be our common factor. Now, if we divide both of our terms by x squared, that means I'm pulling out 2 x's. What's remaining? On the left side, just x. On the right side, just 4. And so that would be our solution to the factor. Next problem, 12xy minus 8x. All right, so now we can see I have a common variable factor. Let's see, do I have any common numerator, a number factor? 8 and 12, well, sure. 4 goes into 8, 4 goes into 12, so our GCF would be 4x. So again, we want to divide both of our terms by 4x, which we'll see that x is a common factor. 4 goes into 12 3 times, and we're left with 3y minus 4x and x simplify out. 4 goes into 8 2 times, and on the right we're left with 2. So our factors are 4x and 3y minus 2. Ooh, it's getting messier, isn't it? Well, let's look and see what we have. If you need to, again, write your solutions out in expanded form. 4 times x times x times x times y plus 10 times x times x times x times x times x times y times y times y. That makes it a little bit easier for you to see exactly what your common variable factors are. I see 2 y's in both sides, so that would be a y squared. I see 3 x's in both sides, and so that would be an x cubed. And then I just need to find the common factor between 4 and 10. Common factor between 4 and 10. 4 doesn't go into 10, but 2 does. All right. So we're dividing both of our terms by 2, xxx, yy. 2, xxx, yy. So I can see my x's will simplify out, my y's will simplify out. 4 divided by 2 leaves me with 2 on my left side. Plus, my x's will simplify out there. All right. Y will simplify out, y will simplify out. 2 goes into 10 5 times. And so we have 5 left as a numeric value. But notice, I still have 2 x's. And I have a y that was not crossed out. So those would be our factors. 2x cubed y squared times the sum of 2 plus 5x squared y. All right. Now I'm going to give you several problems. I'm going to ask you to go ahead and just take an opportunity to work them out. So I'd like for you to pause between each one, work it out, come check your answer. Pause, work it out, check your answer. All right, welcome back. 18x minus 27. We should have determined that our greatest common factor was 9. 9 goes into 18 2 times. 9 goes into 27 3 times. All right, welcome back. We can see that we have an x in both terms, so x is going to be part of our factor. 12 doesn't go into both terms evenly, but it looks like 4 would go into both terms evenly, so let's try 4x. All right, 12x squared divided by 4x leaves me with 3x. And 40x divided by 4x leaves me with 10. So we end up with 4x times the difference of 3x minus 10. All right, welcome back. 24 and 15. Well, not 15, not 10, not 5. Maybe 3. Looks like 3 is going to be our greatest common factor. And then variable-wise, both of them have at least 2 y's in them, so y squared. So let's divide by 3y squared. Y's will simplify out. 3 goes into 24 8 times. Let's divide by 3y squared. 3 goes into 15 5 times. 2 y's are canceled out. That leaves me with 1 y left. And we finished the problem. All right. 10 and 34. 10 has factors of 1, 2, 5, and 10. The highest of those that will go into both numbers, 2. looks like there's an m in both terms. Oops, sorry. Let me get rid of that. 2, there's an m in both terms. There is an n in both terms. So we want to divide by 2mn. Well, that will cancel out one n. That will cancel out the m. 2 is divisible, or 10 is divisible by 2 5 times. All right, let's do the same for the other. 2mn. N's will cancel out. M's will cancel out one of each. 34 is divisible by 2 17 times, with one m remaining. 12x cubed minus 4x squared minus 20x. Well, now we have more than just two terms, don't we? So we've got to look at all three terms and see what is our common value or our common factor. All three terms have at least one x. 12, 4, and 20 are all divisible by 4. So we're going to divide every one of these terms by 4x. Four goes into 12 three times. And notice I had 3 x's. We took away 1 x, and now I have 2 x's remaining. 4 goes into 4 one time, so minus 1. Let's see what's left in our variable. One of my x's is going away. That'll cancel out that. And so we are left with 1x. Minus 4 is divisible, or 20 is divisible by 4 5 times. My x's will simplify out, and so we end up with a solution. All right, it's getting more complicated still. You can do it. Welcome back. 28, 21, 42. Each of those appears to be divisible by 7. All right, we have 3 x's, 2 x's, and 1 x, so we can only pull out 1 x from each term. We have 2 y's, 4 y's, and 2 y's, so we can pull out 2 y's from each term. So we're dividing each term by 7x y squared. Y squareds will cancel. X will cancel one of my x's. 7 goes into 28 4 times. So we're left with 4x squared. All right, next term, 7xy squared. So we cancel out 1x, cancel out 2 y's. 7 goes into 21 3 times, so minus 3xy squared. Last term, 7xy squared. Y squareds will cancel out. X's will cancel out. 7 goes into 42 6 times. Difference of two squares. Now, yes, I did put two squares on the screen, and yes, they are different. But no, these aren't really the different squares that we're looking at. We're looking at difference of two squares. And we talked about difference of two squares a little while back in Unit 1 when we were foiling. And so you may have remembered that I gave you a problem like x plus 4, x minus 4. And I told you some of you would figure out that there is a shortcut to a question like this. But let's go ahead and do the long process. X times x is x squared. X times negative 4 is negative 4x. 4 times x is positive 4x. 4 times negative 4 is negative 16. All right, and my negative 4x and positive 4x cancel each other out, and I'm left with x squared minus 16. And so we get the term difference of two squares because difference implies we're taking subtraction as our operation. And the two squares, notice the value to the left of the subtraction is a perfect square. The value to the right of the subtraction is a perfect square. The value to the left of the subtraction is a combination of the term x times x. The value to the right of the subtraction sign is a combination of the terms 4 times 4. Both of those are squares. Now, I said you can do this very quick for any problem. Doesn't matter what I give you. X minus, 13. X plus 13. Now, when I have x minus 13, x plus 13, I should be able to now jump to, I recognize these are the same binomials. One has a negative, one has a positive. X squared minus 13 times 13 is 169. Now that's our slight review of difference of two squares. Please be very careful to not confuse that with x plus 4 times x plus 4. This is simply a value squared. X times x is x squared. X times 4 is 4x. 4 times x is 4x. 4 times 4 is 16. So we end up with x squared plus 8x plus 16. Notice, when we square a value and the sign is the same, we're going to continue to have three terms, a trinomial solution. When we multiply two binomials that appear the same and the only difference is the operation signs are opposite, our two middle binomials are going to cancel, our two middle terms are going to cancel each other out, and we will end up with a difference of squares binomial. So let's factor. Notice I have a square that is x times x. I have a square that is 7 times 7. And I have a subtraction sign. So we have the difference of two squares. X plus 7, x minus 7. All right. Well, this doesn't quite look the same. Is it still the difference of two squares? Let's check. 9x squared, 3x, and 3x, right? Sure. And 16y would be 4y times 4y. Well, those are two squares. So our solution is going to be 3x minus 4y times 3x plus 4y. Notice all I did was separate the two squares, put a subtraction sign in one and an addition sign in the other. $50x squared minus 32. Now, as we continue factoring, you're going to notice the very first thing you're going to want to do is look to see, is there a GCF that can be first factored out? So, in this problem, I can see that I can factor out a 2 from both of these terms. If I factor out a 2, 50 divided by 2 leaves me with 25x squared. 32 divided by 2 leaves me with 16. Now all of a sudden we have created a binomial inside the parentheses that is the difference of two squares. So I'm going to ignore the 2 for just a minute because it will eventually drop down to wherever our final solution is. But we're going to factor just the binomial. And since it's a difference of two squares, where we have 5x times 5x and we have 4 times 4, we can write out our binomial as two binomials, 5x plus 4 and 5x minus 4. And now I told you we were going to bring the 2 down when we are all done factoring out our difference of squares binomial, and that's what we're going to do. We're going to bring it down and put it in front of our problem. That is your final solution. x to the fourth minus 1. Okay, x to the fourth. That's not a square, is it? Well, it can be a square because remember, there are two terms that are getting multiplied together. X squared is getting multiplied to x squared. Well, what about 1? 1's not really a square, is it? Well, sure. 1 is getting multiplied to 1. Okay, so let's try the same process. X squared plus 1 and x squared minus 1. Wait a minute. Let's not be so quick to think we're done, are we? I have created another difference of squares, haven't we? We have. And so what we're going to do is we're going to ignore this first binomial for a second. We're going to look just at the second binomial because it will split up. X squared is a combination of x times x. 1 is a combination still of 1 times 1, which means we can split this binomial again into x plus 1, x minus 1. And just as we did with the 2 in the previous problem, we're going to bring our other term down because we cannot simplify it any further. And so our solution, x squared plus 1 times x plus 1 times x minus 1.